How to find out if 7, 11, 13, or 17 is a factor of a positive whole number. The process of determining if a number has 2 or 5 as a factor is easy. Look at the last digit. If it is even, then the number has 2 as a factor. If it is 0 or 5, then the number has 5 as a factor. To determine if a number has 3 or 9 as a factor, add the digits together. When you convert the digit from representing tens to representing ones, you subtract 9 times its value from the original number. Doing so preserves the divisibility by 9. To analyze whole numbers, let's define U equals units digit, T equals tens digit, H equals hundredths digit. Then we can consider a 3-digit whole number as H, T, U, where the H, T, and U represent the digits. That way, when you add the digits of H, T, U together, you get H plus T plus U. But the number really was 100 times H plus 10 times T plus U. So H plus T plus U is the original number minus 99 times H minus 9 times T. H plus T plus U is the original number minus 99 times H minus 9 times T. Or we can say H plus T plus U equals 9 times the quantity 9 times H plus T. We really don't care what is in the parentheses here, except to note that it is 9 times something or other, some whole number, so the original number will divide exactly by 9 if and only if the sum H plus T plus U also divides exactly by 9. This reasoning holds even for numbers with more than 3 digits. For very big numbers, you may have to add the digits of the sum of the digits, doing the process twice or more. And if it works for 9, then it works for all of the factors of 9. Here, 3. On to the harder factors. It's a stepwise process for each of them. First, erase the last digit. Second, do something to the remaining digits that has to do with the digit you erased. Third, look at the new number, which is 1 digit shorter. Either you can say that the new number does or does not have the factor you are testing, or you do the process again, removing another digit. This process is one of taking a big unfamiliar number and exchanging a shorter, simpler number for it, in such a way that if the big number had a specific factor, then the smaller number has it too, and vice versa. Eventually, you will have a small number and will recognize it as having, or not having, that factor. You will need to know the multiplication table for 11, 13, and 17 from 1 to 10. The rule for 7. Cancel the last digit, subtract twice the old last digit from the number you get, and continue that process as often as necessary. Doing so is subtracting a multiple of 21. That's how it works. The rule for 11. Cancel the last digit. Subtract it from the new last digit also. Doing so is subtracting a multiple of 11 from the number. A pair of repeating digits, if it is a 2-digit number, is an exact multiple of 11. In this example, you will see that a mile is a multiple of 11 feet. The rule for 13. Cancel the last digit, add it to the new last digit. Don't subtract, add. But you subtract it from the new next to last digit. Begin with the number HTU, which is 100 times H plus 10 times T plus U. Cancel the last digit, getting 10 times H plus T. Add the old last digit to the new one, getting 10 times H plus T plus U. Subtract the old last digit from the second last digit, getting 10 times quantity H minus U plus T plus U. Repeat this process, shortening the number by 1 digit at a time, as often as necessary. How does it work? Begin with HTU, which is 100 times H plus 10 times T plus U. End with 10 times quantity H minus U plus T plus U. For convenience, let's leave the 0 at the end of the number you are working with, 100 times quantity H minus U plus 10 times quantity T plus U. The difference must be a multiple of 13 to preserve the ability or inability to divide exactly by 13. The difference is 100 times U minus 10 times U plus U, which is 91 times U or 91 times some whole number or other, but 91 is 13 times 7 and has 13 as a factor. So the ability to divide exactly by every factor of 91 is unchanged by this process. 91 is 7 times 13. So you can use this method to test divisibility by 7, too, but it is more of a pain than the method I showed you earlier. By the way, leaving the 0 at the end is okay because after the algebraic maneuvers to put a 0 at the end of the number, canceling the 0 is dividing by 10, leaving the other factors intact. The rule for 17. This is a little tricky. Cancel the last digit, divide that old last digit by 2. If it is even, then subtract that quotient from the tens place of the new number. If it is odd, then there is an either or step. If it is odd, you have to do one or the other. Subtract the integer part of the quotient from the tens place, rounding down. Then either subtract 5 from the units place if the units place is 5 or more, or add 5 to the units place and subtract 1 from the tens place. How does it work? Begin with 100 times h plus 10 times t plus u, and you end with, if u is even, 10 times h plus t minus 10 times 1/2 times u. If u is odd, you get 10 times h plus t minus 10 times 1/2 times greatest integer of u minus 5. So one way or the other, you are going to end up with 10 times h plus t minus 10 times 1/2 times u. Odd u or even u, we don't care. Multiply the end result by 10 to simplify the algebra here. 10 times the end result is 100 times h plus 10 times t minus 50 times u. And the difference is 51 times u. 51 times something. 51 is 17 times 3. So this process removes one digit and leaves the factors of 51, here 3 and 17, intact. The lessons here. Don't let anyone tell you that determining if a number divides by 7, 11, 13, or 17 requires doing the division outright. Also, you now know how to do it.